So yeah, welcome. So in case you're new to this or you just want some more information, VicHack is a hackathon hosted by 5 clubs. So us at Hack Melbourne and DS Cubed at Unimelb, and then Mac and MDN at Monash, and then Risk at RMIT. So we wanted to put this hackathon together so you guys can get some experience like building projects and like meeting new people and all that good stuff. So in terms of how the hackathon works, there's 4 core streams. So AI, blockchain, mobile dev, and data science. And of course, this is the data science stream. Each stream has their own workshop. So today is obviously the data science workshop, and on Monday we have the blockchain one, and then next week we have the mobile dev and the AI one. So I think that's all from me for now. If you guys want any more information, we have our Discord here, and we have our Instagram as well, where you can see all the upcoming updates and all that sort of stuff. So yeah, I'll hand it over to Daksh, and he'll go over a bit more of the data science workshop. Yeah.
So hello everyone, welcome to VicHack. I am Daksh Agrawal. I'm the current education director at DS Cubed. And well, we make a lot of decisions every day. We decide when to wake up, where to go for a jog, and how long to jog for, which toothpaste to use, which route to take to university, where should we study, should I participate in VicHack or not, what do I get for lunch, how to reach back home, where should I plan my vacation, and where to go out, which drinks to buy, which subjects should I take, and the list goes on. So your experiences shape your beliefs shape your decisions. And frankly, as 18 to 20-year-olds, you don't have a lot of experiences. And this is where data comes in. You don't have to rely on your own experiences. A lot of students like you have tried different options, have taken different decisions, and you can learn from them. We collectively have such great wisdom about everything that can lead to ideal decisions every day in every part of our life. So this is where data science comes in. Well, you could go through every experience individually and shape your decisions. From experience, do not spend days reading toothpaste reviews on Amazon. So as data scientists, your job is to look at the data and turn it into actionable insights and personalized recommendations. You have these neat algorithms that can go through huge chunks of data and guide your decision making, be it through insights into the data that can find the best performing car models, or recommendation algorithms that can look up amazing subjects that students like you have loved and you would probably love too. So great data science can lead to great decisions, and in VicHack, you will build something that will allow you to make data-driven decisions every day. So we want you to give us a peek into the future, an innovative future that is shaped by your data-driven decisions. So over the next 2 hours, Bike and Thomas will teach you some basics of data science to get you started on the journey, but think of these as starting points. Go beyond what's taught, think of new ways to collect data, and gain insights to make them part of everyone's life. Good luck.
All right, so for the first part of the workshop, we'll be going with some machine learning basic concepts for you to understand, and then actually how to create your own very model itself. So the first thing to consider is, what is actually machine learning? Well, it's actually the automatic process of extracting useful and meaningful information from a given data set. Don't worry about this too much. We'll go over some examples for you to fully understand the concepts of this idea. Now, there's 2 types of machine learning methods. There's the supervised machine methods and unsupervised. So for supervised machine learning models, the AI itself actually has a distinct goal and outcome it wants to reach. It has something it wants to predict. So its main focus and goal is to actually learn the features and attributes themselves to predict the certain outcome variable desired. For unsupervised learning machine models, there's no distinct goal or outcome it wants to achieve. There's no right or wrong answers. What it's trying to do is that it's trying to learn hidden patterns and actually distinct structures within the data itself. We'll go over a lot of this throughout the next few slides. Don't worry about that. So just to reiterate, supervised machine learning, they learn from the features and attributes of the data to predict an outcome variable. Right, let's give you an example of this. Let's say we have a car that's made in 2021 with the brand Tesla, Model 3, it's white, and it's currently sold in Melbourne, Victoria with 80K miles. Now, your job is to actually predict the price of this car. However, you're actually no car expert. However, what you do have is actually a large database of different types of features of different types of cars with different varying prices. Now, what can you do with this large data bank? You can actually put this into a model. What happens is when you give data to this model, the model will learn the features of the cars to predict the price of a car for you. So once the model's trained with this new data, what it can do then is you can actually give it the car that you want it to predict the price of. It will assess the features of the car and give you, voila, a predicted price for the car. Now, in terms of creating your own machine learning model, there's actually two phases. There's a training phase and there's a test phase. During training, what you do is you actually train the model with the training data. Once the model is trained, you then want to assess the performance of the model, right? So once it's trained, you give it new extra data that it hasn't seen before, get it to predict such data, and then assess its performance. Then you can actually look to improve it. Now, what's the purpose of a machine learning model? Well, it's for when you have questions that you don't actually know the answer to. What you can do is you can ask the model this real-world query that you have. It will give you a prediction, and that prediction will give you an idea of what the actual answer might actually be. Okay, let's actually dive into what actually is going on inside. First, however, we have to look at what types of problems that the supervised machine learning is actually going to solve. So there's two types of problems that a supervised machine learning model can solve. There's regression type problems and there's categorical type problems. We'll go over the regression type problems first. So regression type problems is when you're trying to predict something and the outcome variable is something continuous and an integer. So this could be, for example, a house of a price, the stock market trends prediction, or say plane ticket price predictions from when you want to travel from one location to the other, or what the expected fee will be. And this could also actually be stuff like gas emissions, when you're trying to assess how environmental a company is, for example. Cool. So let's go back to our car price example, yeah? Let's think back to the basics here. Let's try and predict the price of a car with just mileage now. So when we do this, we plug data points to the graph, as shown below. We have the predictor variable mileage and the response variable price. And this is, high school stuff, right? Now, who can tell me if the car that I'm trying to sell has a mileage of 65, what would our expected price be? Any volunteers? Come on, guys, you guys are high school students. Surely someone knows. Yep, around 2,000. Anyone has any other opinions? Any numbers you want to throw out? No wrong answers. Cool. So it'll be around like 2K price according to the graph. Now, we can actually take this a step further. Instead of just trying to use mileage to predict the price, we can actually add in another variable. Let's say we want to add in year. Now, if you look at the graph, we actually have a 3D graph, and our line intercept is actually now represented as a plane. Now, if you look closely at the equation, we have y, which is still our predictor, which is still our response variable, price. This time we have two gradients, which are B1 and B2 for mileage and years respectively, with an intercept of B0. Now, you can kind of see where I'm going at here, right? As we add in more attributes, the graphs you'll get will be of a higher and higher dimension plane. Now, first of all, this is actually hard to visualize, but also hard to compute as well. This leads us to our first supervised machine learning model called linear regression model. Now, the model is actually based from this equation of a hyperplane, where y is our outcome variable with b0 plus x1 b1 plus x2 b2 to xn bn, and being the number of attributes that we want to add to the hyperplane. Now, during the training phase, what the model is actually trying to do is it's trying to find the most optimal weights, b's, for each attribute to predict y given the certain x instances that we have. So for a car example, Y would actually be our price, and B1 to Bn would be the weights for each of the individual attributes that we have. So we would have year, brand, a weight for year, a weight for brand, a weight for model, a weight for color, the city, the mileage, and the VIN number. So this is a linear regression model for linear type problems. Let's go into the categorical problems now. This is when the outcome variable is a nominal data. So, for example, if you have a picture and you want to identify if the picture is a dog or a cat, those are nominal values, dog or cat. That is a classification categorical type problem. Or another example is if you want to see how good a movie is or predict how good a movie is, from a star rating of 1 to 0 being from bad to good. Another example actually could be if you're trying to identify a person and trying to classify them into a certain individual group. Now, let's actually give an example of this. Give me a sec. Let's say you're at a park, and everyone on the right is a kid with yellow shirt playing basketball. And everyone on the right is a university kid dancing to music wearing blue shirt. And out of nowhere, random ghosts started appearing. Your job as a data scientist is to help identify these ghosts and actually categorize them into a group. Now, for this first case scenario, can anyone tell me which group this ghost is likely to be with or to identify as? Anyone? Let's have a show of hands who thinks the ghost belongs to the kid group, yellow shirt playing basketball. All right, half the room. Okay, that's interesting. Right, anyone thinks that the ghost belongs to the left-hand group with university kids, blue shirts, playing basketball? Is anyone unsure? No? Well, yes? Oh, wow, okay. That's fine. The correct answer is quite obvious. There's no hidden tricks or anything. The ghost that the group belongs to is actually with the kids. Right. What about this one? Can we have a show of hands who thinks the ghost belongs to the university kids in blue shirts dancing to music? All right, more hands. We're more confident now. That's much better. Come on, guys. Right. Yeah. So that's pretty much the answer. Okay. What about this next one? Can we have a show of hands who thinks that this ghost belongs to a group of kids playing basketball? Can we have a hands to show that the ghost most likely is a university kid in blue shirt dancing to music? And who's unsure about this one? Yep. And that's fair enough. That's actually quite hard to classify, right? This brings us to the next supervised machine learning model. It's called KNN, K nearest neighbors, and its aim and objective is to classify a new instance using the closest data points. So how the algorithm works is you have K number of nearest neighbors. You first calculate the K number of nearest neighbors, then you use majority voting to determine which group the test case actually belongs to. So let's give you an example. Say the number of K is 1. So we find one nearest data point towards to the test case instance, in which this case is just one red point, and hence would identify that test case instance as group from the red group. Right, however, if we have K equals 3, what we first do is find the 3 nearest data points towards the test case instance. Now, what we have here, the 3 nearest case this time is test cases. The 3 nearest data points this time contains 1 red and 2 blues. With majority voting, we would actually classify this data point this time as from the group as a blue data point from the blue group. And that's an example of K nearest neighbors. Now, for this next model that I'm going to show you, I actually want you to imagine yourself as a little boy wanting to play soccer. Now, so you want to play soccer, and the first thing you do is actually you ask Mom, hey, Mom, can I go play soccer? So what Mom does, she looks outside the weather. She sees that it's extremely sunny and with high humidity. She thinks it's way too hot for you to go outside. So she says no to you going outside. Next day comes along, Still sunny, however, this time the humidity is actually low. So she thinks it's fine for you to go outside. She says yes. Next day, there's a bit of cloudy, overcast. She thinks it's fine. She lets you stay outside. Now, for this next one, it's rainy with high winds. What do you think she would say? Can you have a show of hands to see for people who think she will say yes to going outside? Or at her to say no to going outside? Yep, that's fair enough. This case, she says no. Next day comes along, it's rainy, however, this time the winds are actually quite weak. So she thinks it's actually fine for you to go outside, get wet, play in the mud, it's very chill. So she says yes. Now, this brings us to decision tree machine learning models. The aim of this model this time will be for us to determine if we will be able to go outside or not, given the certain scenarios. So a way the decision tree model works is you start with one root node, which is identified as an attribute. Then you branch down to other attributes and nodes until you get the answer to your question. So let's look at this decision tree as an example. Our first root node to start with is Outlook. Now, we have first 3 scenarios for Outlook. First is sunny. First is when the weather is sunny. Second is when the weather is overcast. And lastly is when the weather is rainy. Now, as we can recall, every time that the weather has been overcast, Mom would always say yes to us going out. So for this decision tree, when the outlook is overcast, we would predict yes to us going out. However, that's not the case with sunny or rainy. Whenever it's sunny, she would sometimes say yes, or say no. We actually need more information to actually determine if she'll be able to say yes or no. So what we do is we use humidity as an attribute as well. So from outlook, we go down to sunny, and then with humidity, we'll determine if she'll be able to say yes or not. So if you can recall, whenever it's sunny, with high humidity, she would actually say no to this. And when it's sunny, with low humidity, she would say yes. And this is the same case with rainy and wind as well. Sorry?
Speak a little louder.
Oh, yeah. Cool. Okay. Let's see you guys try to make your own decision tree models this time. So this is a class of attributes, and what we're trying to predict is tennis. And yeah, have a go at it. Try and you create your own decision trees. Alrighty. I assume you guys have had a decent attempt at it at least. Right. So let's just a quick answer for you all. It's an example from dataset. Anyone got this right? Or close enough to it? Perfect, that's good. Close, halfway there. That's all right. This one's quite hard to do given the information we've gone through. Cool. So for our next thing, we're actually going to talk about supervised machine learning models. Now, just to refresh our memory, supervised machine learning models have no goal or something to predict. It has no distinct outcome that it wants to achieve. So what the model's actually trying to do, and its main aim, is to learn distinct structures and hidden patterns within data itself. So this, for example, could be finding hidden groups and clusters that are similar within populations. So let's go for an example. Say you're a teacher with a bunch of students, and you want to form study groups. So what you tell them to do is you tell them to get up and then find people who have similar IQ and study like sessions with you. And once everyone's sorted that out, you'll see something like this, where we can clearly see that there are 3 distinct groups and clusters. Now, let's say that we have a new student coming in, and we want to be able to know which group this student actually fits well with and actually could work well with. We can actually form decision boundary lines to be able to help us, give us an indication of where this new student, which group this new student will likely work well with. Another example of unsupervised learning model is, let's say we have the geographical locations of each student. What we can learn from this is that students from different regions or a particular area can actually have a higher IQ than others. How can this be useful? Well, it could be useful for, say, like recruiters who are trying to headhunt, or it can actually help governments determine which areas are performing lower than others to help give them more support. Now, there's a lot more of supervised and unsupervised machine models that we haven't gone through. So this includes for supervised machine learning models such as support vector machines, naive Bayes, random forest, and also neural networks. For unsupervised, we haven't covered things like k-means clustering or hierarchical clustering, but you can have a look at all these in your own free time. So that's enough theory for now, yeah? Let's actually figure out and learn how to create your own machine learning model. So the first step is actually sourcing our data. What questions do we need ourselves? Well, the first question we should be asking is, what is the right data type? What attributes and features should my data have? And what is my model actually trying to predict? Yeah? So let's give you an example of this. Let's say, like back to our original example, we're trying to predict a price of a car. Now, we have two data sets about cars here. And if we just have a look at it, can anyone tell me which data set would they prefer more over the other? Would you prefer more over the other to actually help you predict the price of a car here? So you're trying to choose a data? Yeah.
Number one, because you can see the type data that you work with, so you can make them all synchronized, easier to work with.
Yep. So I guess the first thing is that, the attributes actually relate to a car and help you predict the price of a car as well. And attribute 2, it has a lot of random attributes that we actually don't need to know about. So stuff like manufacturer name, EU standard, domination, what the hell is that? We actually don't need to know that to actually help us predict the price of a car. Cool. So that's a data set sorted. So we've sourced our data set. We know which types of attributes we want and what we're trying to predict. The next step is to actually ask ourselves if all of these attributes in the data set are actually useful to us or not. So we have stuff like the year it was created, the brand, the model, the color, and the city. Now those are actually useful features. But what about VIN and lot? Those are numbers and strings that actually are only identification numbers of the car itself. They don't actually provide us any information about the car or the features of the car to help us predict the price. They're simply names and identification numbers. So what we want to do is we want to get rid of these attributes that actually don't help us predict the model and actually might confuse the machine learning model. Another key thing to note is once you actually look at your data set, you'll find that raw data is actually never perfect. You'll find a lot of missing values, and actually some values within certain attributes actually don't even make sense, as shown below. So, a solution to that? Well, in data science, we have this thing called data cleaning. What is data cleaning? Well, it's the transformation of data into a readable form for a machine learning model. Let's give you an example of this, shall we? So let's say we have an attribute called transportation type, and it has certain unique values such as flight, plane, bus, train, and car rental. Now, as I've highlighted here, flight and plane, although are two different values, they share the same meaning. This is actually a problem. And can anyone guess what this problem might actually be? This is a hard one, but there are no stupid answers. Genuinely.
The machine will categorize as two different transportation, but actually they're one.
Yes, perfect. That's exactly what I'm looking for. So despite being two different values of this, the problem is that machine learning actually categorizes them to as two different things with this, despite being the same value. I'm just reiterating, we get it, you know your stuff. All right, so how to solve this? Well, if we look at the trend of the data, the transportation type unique values consist of bus, train, and plane, which are vehicle types. So we would want to change flight values into plane, which are similar values and data types to what we already have. Now, another key issue is that machine learning models actually can only take in numeric values. So what we actually have to do is we have to change all words and text, so nominal data, into numerical values. And solution to this? We use label encoding. What is label encoding? Well, it's literally what I just described. We're changing text and words into numerical representations. So if we had color, for example, we would change red to 0, green to 1, and blue to 2. There are actually a lot of different types of encoding. So there's frequency encoding, order encoding, and mean encoding. Each will vary depending on the use of data and what the data type is. You can actually have a read at this in the website below, and we'll provide more information on that as well. Okay, so it's been a long day. There's actually quite a few stuff that we've covered, but we're almost there, but not done yet. So just to refresh everyone's memories, there's two types of machine learning methods, supervised and unsupervised. Supervised, there's two types of data, two types of problems I can solve. There's regression type problems, and there's categorical type problems. For unsupervised machine learning models, you're actually finding hidden patterns and distinct structures in the data. So for example, the study group example we came through. Now, and then we've actually gone through to create our own model. Now, once we have our model and we've trained it with the clean data, the next process is to actually assess its performance. Now, how do we do this? Well, what we actually do is we actually split our data set into training and testing, where training will have most of the data and testing will have whatever's left. So let's, for example, say we have an 80-20 split. So the first 80% of the data we'll actually use to train the model, where the model will learn the features to make the outcome label. Now, with the rest of the 20% of the data, what we want to do is we want to give the model its features to be able to predict the class label. We'll there compare the predicted class label to the real one that we have and assess the performance using calculation metrics such as squared mean errors, accuracy test, t-test, and etc. This will give us an idea of how well the model performs, if it's actually ready to be deployed out into the industry, and actually potential insight into actually how we can improve the model as well. So it's actually time for you, well, you can now create your own model. What's next? Well, it's only you that's actually able to use the model. So next we'll actually go over how to deploy it on the internet for others to actually use as well.
All right. Hello, everyone. I'm Thomas, and thank you, Mike, for giving us a good presentation on some basic machine learning model examples. And I'm going to present the deployment section on AWS. And let's say, what's deployment? So after you have already building your amazing machine learning model, you have predicting the stock market prices, the car prices, and some transportation costs for your life, then how to present it to your audience, how to make it usable for your users and clients. So that is what deployment for. And today we are going to deploy the model. After you're building a model, a training model, we are going to deploy the model setting, upload it to AWS, and make it accessible using an API endpoint, using Postman. And you maybe want to build a front end, build a wonderful website for your project, and you can connect it to the API and get the result from AWS. So let's get started. So in order to make it accessible and usable for your clients, we'll use cloud computing. What is cloud computing? Cloud computing is essentially just a group of data centers that's scattering around the globe, provided by the cloud providers. And before the era of cloud computing, we have to build our own data center at our home, and this is called the infrastructure. We have to maintain and build and manage our infrastructure for everyone, and they can access it into our home. So it will raise some security problem and some, of course, which is really tedious. So with the era of cloud computing, we can make use of the cloud provider, let's say AWS, and it allows us to just click it on the website and reserve some virtual machine on their data center and build our own services on top of it. So this is the benefit of cloud computing. First of all, it's on demand, which means you are paying for what you have used. The second benefit of cloud computing is just elastic, which means the workload, the cloud center can deal with the spike of the workload. Let's say you're running a website, and it's like an e-commerce website, shopping platform for lots of people to come in, and you are running a sale, there's a promotion, and people just rushing in to go to websites, and there's a spike of workload. So with the elasticity of the AWS, so it will accommodate to the spike of workload, and the website will be still running smoothly. And last but not least, another benefit of cloud computing is self-service, which means you are just clicking on the website and without human interaction, and they will reserve a virtual machine for you. So these are the three key benefits of cloud computing. So as I mentioned before, we are using AWS, which is the industry leader in cloud computing, and is leading like around over 30% in the market share in the world. And it offers over 200 services on AWS. That includes the basic one, let's say the compute service that is called EC2, some serverless service, there is the Lambda and storage, object storage, S3. It's called simple object storage, so it's S3. We also can build our virtual private cloud. This is called the VPC, so that we can have a private network on the cloud and build our own virtual machine in the VPC. Another one, and to store the data, we'll use the database service, the RDS. If it is a MongoDB, then we use the DynamoDB for the AWS. And there's a lot of that. So we can build RDS is for the relational database. That is the most traditional one. That is the SQL or something like that. And for other more non-SQL database, we have Elastic Cloud for the Elasticsearch database. So lots of servers on AWS. But today we are just using 3 of them. 3 out of the 200 services. That is the IAM, identity and security and identity service. And the other one is the S3, because we are going to store our model on AWS. So we are using S3 to store the files and media. And the last one, and the more important one, is the SearchMaker. So we are going to use SearchMaker to build, you can build, train model, and deploy the model on SearchMaker. But essentially, today we are just training locally, and then upload the model to AWS and deploy it using SearchMaker. So that's the overview of the demo today. And just a question, have any one of you heard any of the cloud provider on the screen? Raise your hand if you have heard any of them. Cool, yeah, cool. That's good, yeah. Because we got other industry popular cloud provider as well. There's the Microsoft, Google, and the last one will be the AWS. As I mentioned before, we are going to use IAM to control the access to AWS servers and resources for the users. And then we are going to use S3, which is called the simple storage service. So its short form is S3, to have a scalable object storage to store the files and medias. And the last one will be the SearchMaker. All right, as you may have already noticed, AWS is not free, but there's a free tier for new users. Even though there's no free lunch in the world, but there's a free tier for AWS. And it provides like 5 gigabytes of standard storage on S3, which is definitely enough for us. And also 125 hours of the instance of endpoint inference per month for the SearchMaker. So 125 hours is around 5 days. I think that will be enough for your hackathon. But that also means when there's inactivity, then that's better to just turn it off, because that it will be wasting your consumption. And another thing that you have to note is that it requires the credit card to register an account on AWS. So, but I believe in the demo that we are going to show, that won't incur any cost. And if you follow the demo, that will be free. Yeah. Here's the architecture diagram that we are going to build later on. And first of all, the client is like the computer, your local computer. And we'll call after we make a model endpoint on SearchMaker, then we'll call the model endpoint with user input. The user input will be included in the API body, the request body. There will be a single or multiple test instances. Secondly, the SearchMaker will help you to predict the predictions on AWS rather than locally, and they will send the predictions computed on the AWS to the client so that we can get the feedback from AWS without running the model locally. After you train it, it will just run it on the cloud, and everyone, just all the authorized one, the authorized user can access it and get the prediction from the AWS from your model. And there will be the S3 involved in the system because that requires the SearchMaker to load it from S3. I like to dive deeper into the endpoint because I realized that there will be some high school student here. The endpoint is just not in a non-technical sense, it's a point of entry for communication between two systems. In a more technical sense, an endpoint is like just a specific URL that API exposes so that you can use it to interact with the server and get some response to it. So actually, we all interacting with an endpoint in our daily life. Let's say you are just browsing the net and you are going to visit a website, then you are making a GET request to the server using the URL of the website, and you get the response from the server. And then the browser is the client here at the graph, and the browser will display the website, and you can see the contents of your website. So every day we interact with around over 100 endpoints maybe. So that's not new to you guys. For SearchMaker, by default, it provides a REST API endpoint with the post method. So why is a post method? Actually, we are just getting the prediction from the server. We are not creating, because if you know REST API before, a post method is for creating resources. A GET method is for retrieving resources from the server. A delete method is obviously deleting a resource. We're deleting a role, instance in the database. A put method is updating a resource in the server. Then we are just retrieving the prediction. We are just getting the prediction. Why we are using the post method? Anyone has any ideas? All good, yeah, all good. The reason why we are using the post method is because we are making use of the request body. We are using the request body to input our test instance so that the model can know what is the test instance. Because if we are following strictly the principle of REST API, the GET method only allows the parameters to be included in the URL. So there's a query part in the URL, and we can only include our input in the URL. But that may be too tedious for test instance inference. That's why we are using the post method here, and they are offering a post method endpoint to us by default. All right, so that's it for the slides for the deployment, and I'm going to have a demo, live demo, to how to deploy it on AWS. So The instructions in the demo will be included in the Notion blog post that will be distributed, shared to you guys later after this workshop. But we are going to we have a model for you, and there's a GitHub repo for the workshop as well. So luckily, we are going to build it from 0 to 100. And if you'd like to follow me, then feel free to do so. And I'll spend like 10 minutes on it. And yeah, feel free to disrupt me if you have any questions. The first step is to just create an AWS account, obviously. Just wondering if is there anyone want to follow the registration steps with me? Or you want to register together with me now? Because that requires the debit card information, email, something like that. Do you guys want to register for the AWS? If not, that's fine. Yeah, if not, that's fine because we're going to demonstrate how to use AWS without the account. I mean, you don't have to register for it. All right, so okay, I go for it very quickly. You just have to open a link here and sign up for the AWS. And because I've already signed up, so I just have to sign in. So here is the homepage for AWS. We go to, first of all, IAM to create a user. Because right now I'm using the root user, but it's not very safe because root users can have lots of permission, and we want to restrict the permission of the user that we're using. So instead of using the root user, we created another user with a weaker permission. First of all, we go to users on the left panel here. And create a user. So because I'm Thomas, and then I'll say Thomas4 and click next. And we will need to create a user group. A user group is to centralize the management of the permission for the users. So instead of just granting the permission to every single user, we use a user group to manage the permission policy for a group of users together. So we can create a user group. Let's say this user group, I'll call it admin because I'm going to give full admin access to this user group. So I'll just click the administrator access here and create a user group. Because the admin user group have already exists, then I'll try admin free. And click next, create user. The user have already been successfully created. Then I'll go back to the user Thomas4, and we will get the access key for that users. The access key is the linkage between your local computer and AWS. So we are going to put the access key to our local computer so that our local terminal can do some command to the AWS. So we will go to the security credentials type and head to the access key. That is the command line interface, and we check the confirmation. Next. And a tag value is just the description of the access key. So because this is on my MacBook, so I'll just call it MacBook. Yep. And here is the access key. Remember to copy it to our save page. Let's say test edit. And paste it here. The second line is the secret key, and the first line is the access key. And Alternatively, you can download the CSV file as well. That includes the access key and the secret key in the file. You can download it as well and just click done. All right, so that's the process to create a user that we'll be using for the local computer. All right, next is to create a role for SearchMaker. So we head to the roles tab in the left panel, and we create a new role for SearchMaker. So a role is like the identity for our AWS service. We give permission to the AWS service so that they can interact with other AWS services, let's say the S3 or CloudWatch. So because we are making a role for the SearchMaker, so we select AWS service, and the service will be the SearchMaker. Yep, and click next. And you have already seen, so because we have selected the service to be the SearchMaker, AWS by default has already given the SearchMaker full access to it. Keep going. We put a role name here. Later we are going to reference to this role name, so we want to mark down this role name. I'll call it just SearchMaker role because I've already created it, so I'll put a 2 here in case of duplication. All right, keep going. Oh, this already exists, okay. 3 maybe. All right, so the SearchMaker free role already created, and it has the full access to SearchMaker. However, just like what I mentioned before, the SearchMaker needs access to S3 because the model file is going to store on S3. So that means at least SearchMaker has a read access to S3. So we go back to the role that we created and go to add permission here, attach a policies, and we search for S3, and we will see the Amazon S3 full access. So we can click to add it to our role. And additionally, we also need the CloudWatch log access. There is the CloudWatch logs full access. So CloudWatch is an AWS service that monitors all the other AWS services. So it provides the logging, metrics, all the monitoring features are in the CloudWatch. So it is overseeing all the other AWS services. So in order to see what's happening in SearchMaker and also their virtual machine, so we want to have we want the SearchMaker to have at least write access to the CloudWatch logs. That's why we have given the CloudWatch logs full access to SearchMaker. And after we selected the 2 new permissions, we can just create the new permissions. Click the add permissions here, and here we go. We got 3 permission policies, then we are good to go. All right. The next steps after we create a role, we'll have to install and configure the AWS CLI. AWS CLI is the tool installed on the local computer so that you can using command lines to interact with the AWS instead of using the console website that we are using just now. Okay. So you can just follow the link over here, open it, and follow instructions. I think it's straightforward. So if you're Mac, just go to Mac and download the GUI install is fine as well, actually. And then after you install the AWS CLI tool, we are going to open the terminal and input our user identity into the AWS CLI. So you can check the version of the AWS CLI. I don't think you can see it, so let me, okay. I hope you can see it now, okay. AWS configure. And you input your access key and secret key here. So this one is the access key. What you have to do is just copy the access key that you saved just now and paste it here. All right, and the secret key as well. So you copy the secret key and paste it here. And the default region name, please make sure that your default region name is AP Southeast 2, which is the Sydney data center, the Sydney region. And the default output format will be the test, or JSON is fine as well if you prefer JSON. All right, so that's the process to configure the AWS CLI. After that, we are going to install the SearchMaker dependency. So the SearchMaker has an SDK for Python, and we are going to use Python. I believe if it is a machine learning project, we are going to use Python. And the SearchMaker SDK for Python is the dependency so that you can interact with SearchMaker and deploy the model to AWS. So you have to install it as well. Just type npm install upgrade and SearchMaker. Yeah, that's it. Because I already installed it, so then I don't want this command. All right. The next step will be create an S3 bucket. So I'm not sure how many of you have heard about S3 before. So S3 is the object storage on AWS, and you can think of it like a folder on AWS for the bucket. But actually, in object storage, there is no hierarchy file structure. So, but you can think of it like a folder for a bucket. So we just search S3 on AWS and create a new bucket. Before we do that, make sure you selected the city region, because we are in the city region and we are going to access and use all the resources in city region. If the service is a per region service, then make sure you have already selected the correct region. Then we have to put our bucket name. The bucket name is describing what files are in the bucket. So let's say I'll say ML deployment. Because the bucket name has to be unique across all the AWS accounts, across all the regions as well. So it has to be unique. So let's say I'll put my name here, Thomas, and 2. Yeah, it has to be unique across all the regions. And continue to scroll down and just create a bucket. All right. So you see I got 3 buckets here. And I think it's time to go to the code after you create the bucket. Yep. So you can download the GitHub repo on the blog post. There's a link to our GitHub repo, and you can download it and open it on VS Code. It's fine as well, or in the Jupyter Notebook, it's fine as well. All right, so you can run all the code cells above. All right. And the deployment section is starting over here. First of all, let me go through the code with you first. Okay. we got a data set called travel.csv, and we are reading the CSV, doing some data cleaning, dropping some columns, cleaning again, some pre-processing, and doing some feature encoding, and the training is over here, and then we do a prediction over here. So it's straightforward. And first of all, we have to save the model setting to our local computer first. Okay, we are using job.lib to dump the model setting. So the model here is called a VicHack because it's a regression model. And we save it to the path under the model folder, and it is called the model.joblib. Before running this code cell, remember to create a folder called the model folder so that you can store your model setting file, and just run it. It's fine. And then you have to zip the model setting file into a file called the model.tar.gset. After that, we are going to upload the model setting file to S3 using the second command. AWS S3, CP is called copy. Copy the model file to S3, and you can put your bucket name here. Just replace the ML deployment Thomas here, and that will be fine. Yeah, because we don't have the access to AWS, then I'll have to configure it again. All right. And that's fine, okay. And then we are going to deploy the model to SearchMaker. So all right, okay. So this is the two most important lines of code over here. First of all, we create a sklearn model instance for SearchMaker, and we put the model data. That is our model setting file that I already uploaded to S3, and we copy the path of the model setting file on S3 and paste it here for the model data. The role is the role that we created, let's say at the start of the demo, and we call it the SearchMaker role, and we just input the role here. The entry point is telling how can the SearchMaker find the model. So the script is over here. You must include the model function. It's called the model_fn, model function here, to tell how the SearchMaker find the model setting. Let's say we got our job.lib.low. Actually, it's very standard. And we put the model directory here because this is also a standard default parameter for AWS, and you must follow it. And otherwise, there will be error, unfortunately. And then, because the folder that we created is called model, so the model file, the folder for the model is called model, just the model, just model. And the file setting, the model setting file will be model.joblib. All right? So this instruction is just telling how the SearchMaker find the model setting file on S3. By the way, how to find the model data path over here? Actually, after you uploaded the model file to S3, let's say that's the model.joblib, and you'll get the object URL over here. Yep. Then you just copy it, and sorry, that should be this one, s3.uri. Yep. Copy this one and paste it to the model data parameter so that the SearchMaker knows where the S3 model file. Okay, all right. So That's the first most important line of code. And the second one will be the deploy command over here. So after you got sklearn SearchMaker model instance from the previous one, you have to call the deploy function. Obviously, very straightforward, and you specify the instance type. One thing to note is that the instance type in the free tier only got M4 X large and M5 X large. So instance type is just like the CPU type of your virtual machine. But you don't have to care about the infrastructure under SearchMaker, let's say the virtual machine stuff and the networking stuff, because SearchMaker is a fully managed service, which means AWS is doing all of the underlying infrastructure for you. And the only thing that you have to worry about is what instance type you are going to use. In the free tier, then you are going to use the ml.m5.xlarge instance. And I think that will be enough for your hackathon. And we're going to specify the initial instance count as well and the endpoint name as well. So you can just run it. No module name SearchMaker, so I have to install it. If I already install it, then okay. All right. Yep. And it takes around 3 to 4 minutes to deploy the model on AWS SearchMaker. So this code cell will take around 3 to 4 minutes. In the meantime, you can go to SearchMaker. And jump straight to the Inference tab, Endpoints. And you are seeing the sklearn prediction endpoint is creating. All right? Yep. And because we give access to the CloudWatch log, which means we are able to see what's happening under the SearchMaker endpoint. And we can just click into this link to fill the log. All right. And just head to the newest one. I think this one. Yep. Maybe not, because the last event time is a few days ago. It's still creating, so okay. Usually, this code cell will take 3 to 4 minutes, and if you have already set up the permission correctly, then that should be all right. Let me talk about the script.py with you together. For the script.py, actually we can do many of things here. Let's say doing some pre-processing of the input here, and some transformation for the output from the model. Because let's say after you got the model prediction, and you want to output a JSON format, but when you have done, if you have done sklearn before, there will be just the prediction. Let's say this is just an integer. However, when you want to give more information to the integer, what is the integer? So we can give JSON object. as the output. Then we can do that transformation under the output.function here. So we got lots of things to do here, actually, and you can explore it on your own on the AWS tutorial. And I think that tutorial is in the Notion blog post as well. So you can have a look at it. These are those more advanced customization that you can do. And I believe you can, if you have time, that you can have a look at it. All right, I think the endpoint is already working, it's in service. You can check out the details here. For the status is in service, and then we can head to the logs for the endpoint. And go to the latest one, then that is for our endpoint. All right, so this is the log for the virtual machine of your endpoint. And you can see AWS is keep sending 200 pin to the virtual machine to checking the health status of the virtual machine and ensure it's working. So you can see what's happening on underlying the SearchMaker in the cloud watch log. All right, and the most important URL here is that's the URL. Yeah, that's the endpoint URL. So that you can call it using Postman. Copy the URL here, and we will paste it to Postman right here. And remember to select the method to be post, because by default, this is a post method API. And inside the authorization, we are using the AWS signature type here. And just put your access key that you just copy at the start of the demo to here, and paste the secret key over here. And then for the AWS region, we are using the AP Southeast 2. That is the city region. And the surface name will be the SearchMaker. So pretty straightforward. And after that, we are using the body to put the endpoint request over here. And that's pretty like the end of the demonstration. And when you make a request, and you got the results here. All right? Yeah, that's pretty much the end of the demonstration. And thank you, everyone. But actually, there's one more thing. The one more thing is, how can we improve our architecture? Our architecture is just the most basic one, and we can integrate with other AWS services, like the API gateway here, to have more and more advanced authorization and authentication. And we can hide the underlying SearchMaker endpoint over here as well. So that's a tutorial on how to integrate the AWS API gateway here with our SearchMaker endpoint so that it's more reliable and more secure. And you can check it out on your own time. And that's the architecture for the improvement. And the other improvement is the IAM, because we didn't follow the best principle. Did you find it? We didn't follow the best principle because we are using just granting the full admin access to the user. And actually, we have to follow the least privilege permissions principle so that we only grant the minimum requirements, the minimum permissions, and that need to perform the task to the users and the roles. So instead of just granting like the full admin access, and we just want to grant the permission that is required. All right, so that's it for the demo. And hopefully you can enjoy, and hopefully have a good time here. All right.